Good morning, SRT. This is Physics 12 Vectors, and what we're looking at today is an example of a parallel. It's part of kinematics, and it's all about not free fall, but close to free fall. What would your acceleration be on something like this water slide that isn't free fall, but it's inclined at 70 degrees below horizontal? So we'll take a look at that problem in just a sec. But an inkling that if you're on this water slide, even though they call it free fall, you're not in free fall. You're not accelerating at 9.8 meters per second squared. But they're saying you're pretty close. So what we'll do in this problem is figure out what is your acceleration when you're declined at 70 degrees from horizontal. This vertical would be free fall. That would be 9.8 meters per second squared. That horizontal would be, you're not accelerating at all. So it would be an acceleration of 0 meters per second squared. Somewhere in the middle, maybe between 0 and 9.8. So maybe 4.5 meters per second squared. Don't know. But we'll do the math though, and we'll figure out what it is for 70 degrees. Is just a part of the slide, could be somewhere in the middle, where it still is 70 degrees. I've just expanded it, blown it up a bit. What I want to look at is a little bit of trigonometry. If I had someone on this water slide, sitting like this, and going down the slide, here's out here, that person on the slide wouldn't be feeling 9.8 meters per second squared acceleration. It's something less than that. But if it was free fall, they would be feeling a full 9.8 meters per second squared. If they fell. But they're not falling. They're going at 70 degrees. So they're actually going in this direction down here. And it's part of the 9.8. You draw that green horizontal component, that's called the A parallel. It's the component of acceleration parallel to the slope. You draw it just far enough down that you have a 90-degree angle between parallel to the slope and perpendicular. So they'll call this A parallel. And they'll call this one A perpendicular. We're not going to worry about the A perpendicular. It doesn't really affect our problem at all right now. You want to draw a parallel part. This parallel part, called A parallel, is less than 9.8. You can see that. 9.8 is the hypotenuse. Just looking at angles here, I've got 70 degrees up here. So if I've got 70, just by similar triangles, if I draw a horizontal line right here, this will be 70, right there. If that's 70, then this one here is 20 degrees. If that's 90, then this one here is 70 degrees. Because 70 plus 20 plus 90 have to equal 180 degrees. Just cleaning it up a little bit, I have a triangle that looks like that. I've got the A parallel component, or part, of 9.8 meters per second squared, and I've got the A perpendicular part. So that one squared plus that one squared has to equal that one squared. This one's the hypotenuse. If that's 70 degrees, that'll be the opposite side, and that'll be the adjacent side. And that's how we will solve what A parallel is. So let's get to it. Just doing a bit of math, I've got sine 70 degrees is opposite over hypotenuse. And opposite over hypotenuse is really A parallel over the 9.8. And I don't want A parallel over 9.8, I just want A parallel. So multiply this side by 9.8, multiply this side by 9.8. You get 9.8 times sine 70 degrees is equal to A parallel. And that is what we're looking for. And when you calculate it, 70 degrees, sine, and then multiply by 9.8, you get 9.2 meters per second squared, which is pretty close to free fall. And if you've ever been on this slide, you know that it is feeling like free fall. You can't really tell the difference between 9.2 and 9.8 meters per second squared. But there's a big safety margin here. If you were to bounce off the slide, you wouldn't actually fall off, even though you're feeling almost free fall.